How refrigerators cool your food. Open your refrigerator. It's cold inside, right? But here's the question. If there's no ice, no wind, and no cold machine, how does it actually make things cold? The answer might surprise you. Refrigerators don't create cold, they remove it. Let's see how this quiet engineering marvel works. The basic idea. Cooling isn't about adding cold air, it's about taking it away from your food and moving it somewhere else. A refrigerator is essentially a heat pump. It pulls it from inside and dumps it outside, using a clever loop of physics and chemistry. Meet the hero, the refrigerant. Inside every fridge is a special fluid called a refrigerant. It has one superpower. It can easily switch between liquid and gas at low temperatures. When it evaporates, it absorbs it. When it condenses, it releases it. That's the secret behind all cooling systems, from your fridge to air conditioners and even freezers. The cooling cycle step by step. Let's follow the refrigerant on its journey. Step 1, compression. The compressor squeezes the refrigerant gas. This increases its pressure and temperature. Now it's hot and under high pressure. Step 2, condensation. The hot gas moves through coils at the back of the fridge. As it cools, it turns into a liquid, releasing it into the surrounding air. That's why the back of your fridge feels warm. Step 3, expansion. The liquid refrigerant passes through an expansion valve where it suddenly expands. Pressure drops and the refrigerant becomes cold and gaseous. Step 4, evaporation. The cold gas flows through coils inside the fridge. It absorbs heat from your food and air inside, cooling everything down. Then it returns to the compressor and the cycle repeats again and again. The science behind the cool. When a liquid evaporates, it needs energy to turn into gas, and it takes that energy as heat from its surroundings. That's why evaporation cools things. It's the same reason sweat cools your skin. Your body loses heat as sweat evaporates. Your fridge does the same thing, but in a closed control system. Temperature control. The thermostat in your refrigerator monitors the internal temperature. When it gets too warm, it tells the compressor to start the cooling cycle. When it's cold already, it turns it off to save energy. Smart engineering, smart balance. Why the freezer is on top or bottom? In other fridges, the freezer was always on top. Cold air naturally sinks in, so it helped cool the lower section more efficiently. Modern fridges use fans and sensors to distribute air evenly, so layout is now a matter of design, not physics. Energy efficiency and modern improvements. Newer refrigerators use eco-friendly refrigerants, better insulation, smart compressors that adjust power as needed. This reduces energy use and makes fridges quieter and longer lasting. Engineering evolution keeps your food fresh without wasting electricity. In conclusion, your refrigerator doesn't make cold, it moves it quietly, continuously, efficiently. By using physics, fluid dynamics, and clever design, engineers turned an invisible principle into an everyday miracle. Every time you grab a snack, you are witnessing thermodynamics in action. Please like, share, and subscribe for more stories about the technology behind your daily life.